We are now going into the section that I think is the most challenging of this chapter, and there's a few pieces of this that are really important. The other ones I'm covering so that hopefully the subsequent sections will make more sense to you. So the idea is that our rotational quantities can be expressed as vectors, but these are a different type of vector than what we've been studying before. And the idea is that you can use the right-hand rule to determine which way the vector goes. So there's going to be a few different ways that we talk about the right-hand rule. This is also going to relate to cross products, which will be in a separate video. But we can think of these as axial vectors, that they really just tell us which way an object is rotating around an axis. So you need to use the right-hand rule for this, and literally you must use your right hand. If you use your left hand for this, you're going to get the opposite answer. So if you're right-handed, put down your pencil or your pen and actually do this. What you want to do is curl your fingers in the way that the object is rotating. If there's an analog clock in the room, you can, for instance, hold your hand up and align your fingers with the numbers, and you can see that as you curl your fingers from, say, 12 to 6, that your thumb is pointing out at you. This picture here shows a wheel that's kind of in out of the page, and that as you curl your fingers in the same direction that the wheel is rotating, your thumb would point up. So the idea is if we talk about the angular velocity of this, we know that it's spinning, and we could get the numerical magnitude based on how fast it's spinning, but then we need to say whether it's spinning clockwise or counterclockwise. So defining this vector to be up or down is really just a different way of saying clockwise or counterclockwise. It might seem a little bit like overkill, but this will be coming back later, which is why we want to think about it right now. So this picture is just to give us an object that's rotating, and to actually look now at some different ways that we can describe its rotation. So one way is to say that it's rotating clockwise, right? We're told that our rotation is this way, and you know that that's like the way a clock goes, right? You hopefully know that by now. So this is clockwise. Now, the coordinate system that the book has used, which up till now maybe hasn't made much sense to you, is that clockwise equals minus. And what I always encourage you to do is actually draw this on your paper, that clockwise is negative and counterclockwise is positive. Now we use the right-hand rule. So as you're looking at this rotation, you want to curl your fingers with it, as if your fingers are showing which way it's going. Now that means that you might start by pointing your fingers up at 9 o'clock and then having them curl towards 3 o'clock. That means that your thumb is going into the page. So into the page you get from the right-hand rule. Now there's one final way to describe this, which I'm going to talk about, which is the idea of our coordinate system. And this is where, if I just say negative z hat, that doesn't mean anything. But if I define my normal coordinate system, where I have x, y, z is then coming out of the page. And so we see that if z is coming out of the page, and we just said that our rotational vector corresponding to omega is into the page, that means it's minus z hat. So this is actually where this idea came from, that in general when we use our normal coordinate system where x is to the right, y is up, z is always out of the page in that case, and that's why we would define clockwise to be minus sign, because that's actually the minus z direction. So this is something, again, a different tool, one that will matter more when we're talking about cross products, but right now all four of these are equivalent. The most important thing is that you're always making it really clear to who's ever looking at your work how you've defined negative and positive corresponding to clockwise and counterclockwise.